Good day, this is Engineer Cranley May Adis Salamanca, and today I will be discussing the Zeroth Law of Thermodynamics. The fourth law of thermodynamics is actually called the Zeroth Law. This law was lately understood, while the three laws have been around already. But the concept of a zeroth law is so fundamental that it should go before the other laws. So, instead of renaming the other laws, this law is named zeroth law. The zeroth law of thermodynamics states that if two thermodynamic systems are each in thermal equilibrium with a third, then they are in thermal equilibrium with each other. In simpler words, if y is in thermal equilibrium with x, and y is also in thermal equilibrium with another body z, thus x is in thermal equilibrium with z. X equals y equals z, and z equals x. This law seems so basic, but it actually mathematically defines the temperature. Bodies reaching thermal equilibrium means that there is already no heat transfer because these bodies have the same amount of heat. If there is a temperature difference between bodies which are contacted, heat will flow from the object that has high temperature to that of the low temperature. Also, it does not depend on the amount of energy that the object contained. For example, if a hot object falls into the ocean, heat will be transferred from this object to the ocean, in spite that the ocean possesses enormous heat energy. Heat transfer will be stopped and thermal equilibrium is achieved when the object has the same temperature of that of the ocean. Another example is that when you place a fresh meat in the refrigerator overnight, the next morning, you will assume that the meat already reached thermal equilibrium with the refrigerator, because basically, heat will flow if it is exposed in unbalanced systems. And that ends my discussion. Thank you.